All right. Good morning, good evening, good afternoon to you all. My name is Gloria. I'm part of the GetCoin events team, and I'm here with Nicholas from Reach. And he's going to be going over the architecture of a Reach app, focusing on an NFT auction. And before we get started, I just wanted to go ahead and go over some housekeeping. First and foremost, this session is being recorded. You'll be able to see this session and all of the other pre-session work on the Greenhouse Hacks playlist on the GetCoin Media YouTube channel. So feel free to take a look there if needed. Second of all, there's two places where you can ask questions. You can ask them in the chat. That's totally fine. The other section is the Q&A, and that's totally fine as well. And if you're watching on YouTube, feel free to ask it in the chat there, and I'll make sure your question gets answered. Last but not least, like always, say hi in the chat. Let us know where you're watching from and what you're working on. It's a great way for all of us to get to know all of y'all, but it's also a great way for all of y'all to get to know each other. And with that, I'm going to hand it over to Nicholas, and we can go ahead and get started.
Awesome. Thank you, Gloria. Like Gloria said, my name is Nicholas Stanford. I'm with Reach. And today I'm going to be covering a high-level overview of what is Reach, the general program structure, and then I'm going to do a live code demo where we're going to live code an actual NFT auction decentralized application built in Reach right here in front of you live. So first, I'm going to answer this question. What is Reach? And let me make sure I've got my screen shared here so I can show you guys my presentation. All right. What is Reach? Reach is a blockchain development platform. It's made up of a programming language, a compiler, and a deployment tool. The programming language has a familiar syntax that's modeled off of JavaScript. The compiler comes with a verification engine. What is that? What is a verification engine? The verification engine creates mathematical proofs and theorems based on your program logic to secure your smart contract against vulnerabilities or flaws. We'll get into the verification engine a lot more later on. The deployment tool. The deployment tool allows you to actually deploy your code to different blockchains. Reach is blockchain agnostic. Today, we're primarily going to be talking about deploying to the Algorand blockchain. So, Reach is a platform to develop our decentralized applications. Here's a little overview of what that looked like. The Reach programming language helps full stack developers focus on the business logic of their programs, right? Again, Reach is very familiar in syntax to JavaScript. So with minimal training, a full stack developer can write decentralized applications with Reach, and most developers are ready to create their first Reach dApp in 3 or 4 weeks, right? Reach compiles and verifies our code to produce smart contracts for multiple blockchains. Again, today we're talking about Algorand, right? Then Reach actually deploys it to the Algorand blockchain, right? Next, after we deploy our smart contract, the smart contract enables participants to interact and complete transactions on consensus networks, right? We say participants, we mean logical actors that participate in your dApp and are associated with an account on the consensus network. When we say consensus network here, we mean blockchain, right? Again, in this case, the Algorand blockchain. So as Reach grows, more blockchains will be deployable through Reach, reducing the need to meticulously understand these low-level programming languages like Teal. Now, let's start breaking down the steps of actually creating that full Reach dApp, right? We begin by defining our participants, who is interacting with our contract. And then we define how their interactions look, right? We call this the participant interact interface. It contains the methods and the values that each of our participants can access. This is done in what we refer to as the backend, the index.rsh file. This is our Reach file, right? Next, the communication model of our program is directed by this participant interact interface. How are our participants actually communicating with the contract, right? Reach developers don't write smart contracts. We build programs that focus on how the participants will interact with the smart contract, and then Reach compiles that program into a smart contract on your desired consensus network. Again, you never need to write teal code when you're dealing with Reach. Next, we compile our program, right? Our index.rsh file compiles down into our build folder into an index.main.mj, as you see here in the bottom left, right? This is our compiled RSH backend. Okay. Reach then compiles bytecode for our intended consensus network, right? So on Algorand, Reach actually breaks this code down into teal to send to the Algorand network, right? This is what we mean when we talk about abstraction. We talk about high-level programming language. We get away from the hardware and we start to build on a level way up here where we have tools and features that help us focus on that business logic of our programs, right? Next, this verification engine that I mentioned, it runs at compile time, right? It relies on certain methods that we introduce into our program to confirm that your program is cryptographically secure, right? It's void of any of the flaws or vulnerabilities that smart contracts face today, right? Again, we'll cover more on this verification engine later, but it's good to start to understand now before we start looking at the code. Next, we move into our front end of a Reach app. The front end can be created with JavaScript, Python, C#, or Go. We can create front ends in different languages with the Reach RPC server. The presentation we're going to do today will be using JavaScript. Next, we talk about how the front end mirrors the back end. Here's our image here where we mirror the front and the back end, right? We use the same method names in the front and back ends, right? This will get a little bit more clear when we start to write code and I start to bounce back and forth between the front and back ends and show you how we define the method in the back end, but we give it functionality in the front end, right? Next, Reach also comes with a JavaScript standard library, right? We call this in the front end, right? You see here in yellow, the Reach standard library, some of the features of the Reach standard library. We say account and address here are almost completely interchangeable, right? Accounts are associated with addresses, right? Our contract here refers to an account that can also store value, right? In its consensus state. Contracts receive and process publications to modify that consensus state as needed, right? These contracts may also transfer network and non-network tokens, right? When I say network tokens, I mean algos. When I say non-network tokens, I mean ASA tokens, NFT tokens, right? These contracts may also provide mappings between those addresses and values, or provide views into the consensus state of the smart contract, right? So here is the full overview of a Reach decentralized application. It includes our front end. Again, today we're going to be building that front end with JavaScript. It includes our back end. This is our RSH or our Reach file, right? And then it also includes the Reach standard library, which we implement in the front end. And we'll see a lot about helper functions from the Reach standard library here when I start getting into code, right? So this is our complete dApp, our complete Reach dApp. Now we want participants to use our dApp, right? Well, Our application is going to use an account, remember, or just a wallet address to access the consensus network, to access the Algorand network, right? The wallet address is how we tell who is who interacting with our contracts, right? Next, the smart contract is actually deployed to the blockchain. Remember, I talked about Reach's deployment tool. This is a feature of Reach that allows you to easily deploy these contracts to the Algorand network, right? Then the network actually includes that smart contract in a new transaction block, right? So it lives there on the blockchain, right? Then our participants, or you can just consider them users in a standard application, can use the contract any way that the program will allow it to. And our Reach app will write to the consensus network as instructed. It will publish information to the Algorand blockchain as instructed, right? So that's our general overview of what Reach applications look like. If you haven't yet, you need to go ahead and get started with installing Reach. This QR code will take you to the Quick Start page. Here's a link to that same Quick Start page, right? There are different instructions. Pull this over here for you to get a quick look. There are different instructions here for Windows, Linux, Mac, right? Make sure that you follow these instructions completely and explicitly to install Reach on your machine, okay? We'll skip over to what the requirements for installing Reach. This is all covered on that same page. Reach requires an installation of Make, Docker, and Docker Compose to be installed on your machine. Reach is designed to work with POSIX systems. So if you are on a Windows system, you need to install WSL2. What is WSL2? WSL2 is Windows Subsystem for Linux, right? It's actually going to install a Linux distro on your machine, a little bit different than partitioning your hard drive, but it's going to install a Linux distro on your machine so that you can interact with Reach from your Linux machine. After you install Reach, you should not interact with your Reach repo at any point from your Windows machine, right? Next, the scaffolding of a Reach app, right? Here are a couple key features. One, as you begin to build Reach apps, you'll understand that Reach updates the language on a bi-weekly basis. Every other week, we're coming out with new updates. So that means you as a Reach programmer is going to need to run Reach update every other week to stay up to date on new publishes and to keep your methods from being deprecated and to just keep from erroneous errors that are uncommon, right? Next feature, Reach init. This creates our boilerplate for us. Remember, we said we have two files, index.rsh, index.mjs. Reach init will create those files and the basic structure for you to get started writing your application right away, right? I'll show you a little bit more on this feature in a minute. The last thing I want to cover in this part of the presentation, modes of a Reach app. This is very important because as I begin to get into the code, I'm going to start talking more about which mode we're in, which step we're in. So this is a reference here, right? So the first thing we're going to do is define all of our constants, right? We're going to define the definitions of our constants, right? And then we're going to initialize our app. We're going to move into this purple, this app init, right? This tells Reach, let's start moving through the states of our program, right? The first one is into step. Well, step just refers to each state of your program. If you're familiar with the state machine, this is very similar where we are telling Reach, here are the states of my application, and Reach knows certain things about the information in each one of those states. Now, next is the local step, right? In blue off to the right there. Local step. What do I mean here? I mean that this is me, the user, interacting with the Reach app on my local side. I am inputting information to the app here at my interface, right? This is necessary when we need our users to tell us what their address is, how much they would like to wager, lots of different information we need from our local step to actually go into the application, right? From there, it either goes into the step or state of the application, or it goes into the consensus step. Consensus step refers to actions involving the blockchain, right? We're writing information to the blockchain. We're paying amounts or quantities to the blockchain. These are stored in the blockchain forever, right? This is our consensus step. When you hear me say this consensus step, right? This is very important as we start to think about how we build our Reach application. So that is the overview, the general overview of what Reach applications look like. I'm going to go ahead and jump over to my VS Code window now and actually start getting into a little bit of Reach code for you. Just a second to get myself back organized. Okay, we should see my VS Code window here. Somebody holler at me if we don't. Close out of these here. Let's get ourselves a new terminal open. Again, you should have your VS Code. VS Code is the supported IDE for Reach. We have an extension for VS Code, and we recommend that you use that. Okay, thanks, Joy. I see that. Thank you. So the first thing I want to do, this is where my Reach install lives, right here in Reach, right? So if I run ls, just show me all the folders in here. This green Reach, that's where your Reach install should live, right? There are a couple different ways to approach this. This is the way I recommend, just for clean file structure. So now what I can do, let's say I want to create a new project folder. We're going to call it present to. We're going to go into that folder and we're going to run reach init. Again, what is this going to do for us? This is going to write index.rsh. It's going to write index.mjs. Okay, well, then we'll come in here and we'll see. I'm sorry, I have a lot of folders here. Let me get to present to. A lot of Reach projects going on here. So these are the two files that were generated, right? Here's our RSH file. It's a Reach file. We're exporting the Reach app. And here are the two participants that we're allowing in our Reach app. Alice and Bob are common cryptography names, and we like to stick to the convention here. So here is that app initialization that I talked about. This tells Reach, let's start moving through the steps, right? If I'm going to tell Reach that, well, Alice is a participant, she's going to tell our app about a wager that she wants to make. That wager is going to be an unsigned integer. Here's where I would declare those definitions, declare the signatures to what they're going to look like. Remember, the functionality is going to be in the front end, right? So this is where our data definitions kind of go. And then we run into our app init, right? And here's where we're publishing information. We're committing to that information. Each one needs to publish and commit before we exit our app, right? This is very rudimentary Reach code. It's organized so that just it will output terminal console log messages so that we can tell that it is running. What messages am I talking? Well, hello, we're launching, starting the backends. So this is what we'll see when we actually run our Reach application, right? Other things that we need to do, let me get this over here. Other things we need to do, well, we need to import the standard library that we discussed. We need to import the back end of our file, which is stored in that build folder that we touched on, right? And then we need to create accounts for for Alice and Bob. We need to create those accounts, fund them with a starting balance, right? And then we need to actually await their actions, right? So this is what the boilerplate looks like. And I briefly touch on this because our next program is going to be significantly more complex, and we'll actually look a little bit closer to what a real Reach application looks like. So now let's see what this code looks like when we run it. What did we call that? We call it present to, not 12, 2. Okay. So I want this to run on the Algorand network. Remember, Reach runs on different networks. So the code that we wrote already is good for different networks, right? But we want it to run on Algorand. So let's tell the Reach connector mode that we want to run on Algo, right? And then let's tell it to run. Remember, we should just get some basic console logs about the state of the application. We pull up my terminal window here, and let's walk through what Reach is doing for us. So here are those terminal or those console logs here that we discussed. Hello, launching, starting backends. And these are console logs are your friend when you want to know what your application is doing from outside your application, right? So there we know it went through the hello, launching, starting backends, and goodbye. It went through everything, right? So let's go back up. Okay, I said Reach run. What did Reach do? Well, first Reach compiled, and it checked for knowledge assertions and theorems. Well, remember, I said the verification engine runs at compile time. The verification engine tells us, hey, I'm going to create some mathematical theorems based on the logic that you used. And I'm going to try to break your program. If it breaks, I'm not going to allow it to compile, right? So we have a pretty simple program. Reach doesn't have any problem with the 7 theorems that we created, so we're good. Then it's going to go ahead and spin up your Docker container for your localized private DevNet, right? This is why we need Docker. And then it's actually going to go ahead and launch and run your app. And that's what we see here. So that is the basic architecture of what our scaffolding of what a Reach program looks like. Okay. So now let's get into something a little bit more fun. I'll go ahead and save it. Let's get into something a little bit more fun. We'll go ahead and start this one in a fresh folder. I'm using the shortcut there, but if you aren't familiar, terminal, new terminal, this is the shortcut here that I'm using, Control-Shift backtick. Or you can go new terminal. But you should be interacting, again, if you have a WSL install like I do here, you should be interacting from your bash terminal, from your Linux home path, right? That's what this little tilde denotes, is your Linux home path, right? Okay, well, which folders do I have so I don't rename it the same thing? Well, let's call it, I'm having a lot of present folders here, but let's call it present 3. Then we're going to get into present 3. Well, now let's treat this without Reach init. Let's just create this from scratch. Well, touch is the command to create a file. We want to create index.rsh. What else do we want? Well, we also want that front end file, index.mjs. Right? Well, now we run this, we should see there's our 2 files, right? And in the same breath, we'll exit our terminal. We'll come over to our file explorer. I called it present 3 here. Here's our RSH file. Here's our MJS file. Let's close those out. Remember, RSH, that's our Reach file, right? We need to tell Reach at the top of every Reach file which version of Reach we're using. Currently, we're using Reach 0.1.11 and some other, but 0.1 does the trick here. So before we get too far into actually building our app, let's talk about the overview of what the app looks like. What are we building? We're building an NFT auction app, right? So it involves someone who creates the sale of the NFT, a creator, and it involves buyers who actually bid on that NFT in algos, right? If the bid is successful, the app should hold the algos, and we should only allow bidding while the auction is active, right? If the current bid is higher than the previous bid, the contract should automatically refund the previous bid and then hold the new highest bid, right? This is how we can trust the application, right? Each bid is actually held inside the contract. We're also going to hold the NFT inside the contract, but we'll get there here in a minute. So at the end of the auction, the highest bidder receives the NFT, and the contract transfers the algos to the creator, right? So that's high-level overview. What does our application do? So the best thing to do when you start these software engineering problems is problem analysis. I almost got ahead of myself here, and I'm not sure if anybody caught me, but I started running Reach code. Oh, sure, let's start writing Reach. Problem analysis should be your first step, right? Problem analysis involves evaluating which problem you're solving. For us, it's the NFT auction. We itemize the data definitions and what types of data are they, right? We make a list of our participants and how they will actually interact with one another and how they will interact with our contract, right? And then lastly, we write all the assumptions that we know about the business logic in our app, right? Assumptions is going to tie directly to that verification engine that we talked about, right? So if you create this in a flow chart, you can easily use that flow chart to translate to an outline, and then use that outline to start expanding on what your code should look like, right? Too many times you start to write code and you write down a kind of one path before you consider all the problems. So if you start with problem analysis, you can actually go from problem analysis flowchart to program outline, and then take that program outline. Sometimes I include it just as comments right in my file. And then, well, that comment needs to do this. How do I make that happen in code, right? So this is how you can start to think of your apps right at the beginning and make it easier for you to design that problem and create more efficient programs, right? So our problem analysis is, well, what problem is our app going to solve? It's going to create a secondary marketplace for our NFT sale, right? Collectors desire to buy those, right? The seller needs to be able to create a new auction for each piece of artwork that they have, right? Then the NFT must actually be held by the contract after the auction begins and until the auction closes. If I'm going to take the algos from the bidder, I am also going to take the NFT from the creator. And we're going to store it in the program. And then we're going to let the program logic dictate who gets that NFT, right? For each bid, the new bid must be higher than the previous bid, right? And then the previous bid will be refunded to the previous bidder. And then the new bid is recorded as the highest bid. And then we're also going to remember hold that in the contract, right? So at the end of a successful auction, the highest bidder receives the NFT and the seller will receive the full bid amount. Next, we're going to talk about data definitions. The necessary data points and their types can now be determined now that we've got our problem analyzed, right? So in Reach, global constants are defined using the const keyword. Right here we say const equals, const temp equals some number, right? Maybe it equals 5. Temp equals 5, right? So our localized backend methods are defined in that participant interact interface, right? And I'll show you that here in a minute. And this dictates the dApp's communication model. The methods in each of these participant interact interfaces are reflected as interact objects in the front end, right? So let's actually start building some code. So first, we're going to start in our RSH file. Remember, every RSH file requires us to declare to Reach what version of Reach are we running. Now, sometimes we use end-of-line characters. Reach does not require it. For this demonstration, I'm going to attempt to not use end-line characters, but I will tell you right now, I will definitely make a mistake and include one somewhere, so don't hold me to that. Let's move on to actually creating our Reach application. On line 3 here, what does that look like? Well, remember that's exporting the constant, what we're calling the main Reach app. Again, I tend to sort of mash on my keyboard, so I will use the backspace key very frequently during this presentation. So just a forewarning there. So here is the actual declaration of our Reach app. Right now, remember we need to tell Reach who our participants are. Well, remember one of them was the creator, right? And they're a participant. What are we going to call them? Well, we're going to call them creator. And then here's that participant interact interface where we're going to tell Reach what this participant can do. So what methods do we need? Well, we need them to get the sale. We say that is a function. Get sale is a function that takes no arguments and it returns an object, right? So what object do we want Reach to return here? Well, if we're telling it about information on the sale, maybe we need the NFT ID, and that is a token. In Reach, token is a special type. We won't go too much into that, but you can check the Reach docs to get more information on token types. We need to tell it what the minimum bid looks like. Well, the minimum bid will definitely be an integer. Then we want to set a deadline. We're going to set that deadline as a length in blocks. And that also is going to be an unsigned integer. What else does our creator need to do? Well, they should let us know when the auction is ready. Well, that's a function. That takes no arguments. And it returns null. What good is that, you say? Well, I'll show you here in a minute. But likely, we just need to let the front end know, let the back end know that we're ready to do something, right? In this case, we're ready to start the auction. So after the auction starts, we want to be able to see what the bid looked like. Well, that also is going to be a function. But that's going to take some arguments. Well, it's going to take the address of the bidder. It's going to take the bid in an unsigned integer. That's going to return a null value, right? And then we need to show what the outcome looks like, right? That also is a function. That also takes in an address and an unsigned integer. This is a null value returned. So what is the difference here? Well, when we're defining our primitive types, right, minimum bid is just a number. But we just tell it it's an unsigned integer. Minimum bid is what we'll call it, and it's an unsigned integer. Well, what if it's a function? What if I need action to happen? Well, you tell it that it is a function. You pass in arguments, either no arguments or as many arguments as you need. And then you tell it the return value. In the get sale option here, that's an object. In the auction ready option here, that's a null return value, right? So that is what the creator can do with our contract. So now let's look at the other participant. Remember, the other one was our bidder, and we store these in constants in Reach, right? So, well, that's a bidder, and they're going to be an API participant. Now, what is API? API is, in this case, is allowing us to create repeat participants who share the same functionality. Each one of our bidders is only going to need to bid. Our bidders do not need any of these functions. Our bidders only need this. They need to be able to bid. Well, what is bid? Bid is a function, and it's going to take a number from that bidder, an unsigned integer. And what's it going to return? Well, it's going to return us a tuple, which is a collection of data types. In this particular example, we're talking about an address and an unsigned integer of who gave us that bid, right? So this is our data definition section. Here is where we've defined all of our data. We've defined all of our functions that we're going to allow, right? And all of the information that we're going to pass between the back end and the front end. So now we're going to do our Reach app initialization. Line 17 here, init. This lets Reach know, hey, move from that data definition into the steps of my program, right? I, the programmer, get to tell Reach what those steps look like, right? So that is the data definitions for the back end. Let's switch to the front end, right? So the front end is in our index.mjs file, right? So this is what our data definitions look like in the front end. Well, we need our imports. Remember, we're going to import the standard library, and I'm going to use some helper functions from Reach here because they give them to us. But here's what it looks like. Import the load standard library from Reach stdlib, right? What else do we need? Well, remember, if we're creating this as a backend, we should probably import it here. We'll import everything as what we're going to call backend. So anytime we need to reference this, we're going to call it backend from, and then we need to give it the path. Well, remember I said it compiles down to the build folder in index.main.mjs. This is what that looks like. This is importing this export, right? export const main. If I were to call this main with a capital M, this program would say, hey, this file doesn't exist, because this is exactly what we're importing here, right? So let's make sure Reach doesn't yell at us, especially for our presentation here. Okay, so now let's move on. Well, we loaded the standard library, but now let's store it in a constant. Now you could go ahead and use load stdlib everywhere, or you just create a constant for it and make it a little bit easier. And now let's create a starting balance, right? We're going to have to create accounts for the testing network here. This runs in a DevNet. Excuse me, this runs in a localized DevNet. So in a localized DevNet, I, the user, cannot input my wallet interface, right? I need Reach to spin up some test accounts for me. We need to fund those test accounts with algos. So we're going to create a constant called starting balance. We're going to use the standard library function, and maybe I back up a second here and say, well, what if I wanted to put 100 algos in there, right? Well, the network deals in micro algos. The network does not deal in algo tokens, in whole algos. So we have a function in the standard library that we call parse currency, right? Parse currency takes what you, the programmer, know is 100 algos and breaks it down into what the network knows as micro algos. So this is an abstraction when I talk about the features of the standard library. There's a key one for you right there. So now let's start actually creating these test accounts. And you're going to see me do a few of these console logs across the program here. Again, I like to know what the program's doing as it's executing so that I know where it gets hung up if anything happens. And also writing these can help you, the Reach programmer, understand what your program is doing. Even if you have to go back and say, oh, well, that says new test account. Now it's creating a new test account. And that just kind of helps reinforce what you're learning here with Reach. So now let's call that, we need to actually get our test account, right? So again, we store that in a const, right? And we're going to call it the account creator. And we're going to let the standard library create us a test account, right? Well, we need to await the standard library to do that. And the function is actually called new test account. You can see right here, new test account. New test account takes an argument. How many tokens do you want to fund with that? Well, remember, we set a starting balance here of 100 algos. So that's where we're going to go ahead and pass in 100 algos to the test account. Now, I should be careful. I say 100 algos, but starting balance actually holds the micro algos because we've already parsed it down, right? So let's keep moving on. And let's get into another, let's give it another console log here. Let's say having the creator create the testing NFT, right? Now, again, this is a test net environment, so we're going to be creating this token out of nowhere. Typically, you can request the token ID number from the user, and that's how it would look in a real application. But again, we're in a DevNet environment, so we're gonna test and create the NFT ourselves. So how do we do that? Well, we like to be very literal with what our constant names are, and we're going to call it the NFT. Now, the standard library also has a function to help us launch these tokens, and well, it's called launch token. So let's use the standard library to launch token, right? Let's see if we hold this up. Well, there are the properties allowed, account that's creating, the name, the symbol, and then what options we're giving it, right? So launch token, we're going to tell it that, well, the account creator is creating this. We're going to call it the Bumple NFT. And the symbol we're going to give it is NFT, right? Well, the last thing we need to let it know is what the supply looks like. How many of these are there, right? In our case, there is just one, right? So that's what creating a NFT from launch token looks like, right? Now let's move in here to grabbing some information about the NFT. We're going to say, well, the NFT ID number equals the NFT. And now we're going to destructure that from the actual NFT object. We're going to grab what we consider the minimum bid. And this is going to be hard-coded, again, because of our test environment. But you could prompt the user and ask them what their minimum bid is. Again, if we want to say it's 2, well, we need to parse currency from 2 to tell reach this is how many microalgos. And then we're going to define our length in blocks, right? We're going to say const length in blocks. Well, let's just hard code that one. That's 10 blocks, right? And now let's set the actual params into an object. What are our params? Well, it's the NFT ID that we just collected. It's the minimum bid that we just created. And it's the length in blocks that we just denoted. Okay, well, now we have our NFT information stored in this params object, right? So now we're going to move down a little bit here, and we're gonna stay in the front end. So before we go to the back end, we're going to create or define, I should say, the creators interact object, right? This object will be created after the bidder's API logic, right? We'll cover that in the next section, but let's get into creating this. I'm going to input some line numbers here just so my guide matches up, but we'll jump way down here to 51. What happens? Well, let's have the creator account deploy the reach application. Well, the account creator is going to use this contract function to attach to our back end. Remember, we called this back end when we imported it. Here is the account for the creator that we've created. We're attaching them to the contract. We're storing that information inside of CTC creator. Okay, so now let's await for that contract information and this participant's native function. Let's actually build out this interface. Okay, well, JavaScript doesn't allow me to forget those, so let's not forget those. So the creator's interact object is going to mirror the backend. Remember I said that mirror, it reflects the backend. Well, what do we have? We have the creator here. What can the creator do? Well, they can get sale, they can auction ready, they can see bid, and they can show outcome. Well, that's exactly what we need to do here, right? So we need to get sale. What should get sale do? Well, remember, it's just going to give us some information about the sale of the NFT. In our case, it is this params object. Remember, params up here has all of the information about the NFT, right? And back here, so here it is. We're going to just return those params. But back here in our SH file, we told reach that get sale was a function that took no arguments, and it returned an object containing the NFT's ID information. Okay, well, here's get sale. Here it is taking in no arguments, and here it is returning that object with those parameters set, right? So this is what we mean when we say that it mirrors, right? So now I'm going to go ahead and just let myself know when the program is running what's actually happening, right? So the creator is going to set the parameters of the sale. And then we're going to go ahead and pass the params so that we can see those on the way out. Well, what else was in our interact interface? Well, remember auction ready was in there, right? And that took no arguments as well. Okay, we're going to miss that key a few times. That took no arguments as well, right? What did auction ready do? Well, it took no arguments and it returned null. Okay, so that's just us sort of pinging the other end to let it know, hey, we're at this process, this point in the process. So let's just create ourselves a function that we're going to use. And we'll give this some functionality here in a minute. Well, what else was there? Well, there was cbid. What parameters did cbid take? Well, it took in an address and it took in an unsigned integer. It returned us null. So let's go ahead and give it the address. We'll call that who, the amount, and we will go ahead and let it return null. So this is us displaying the information to the console, right? Typically, you would display this a little bit differently if you were using a front-end interface, but for our command line program, we're just going to log it to the console. So the creator saw that, well, what did they see? They saw that the winner, which is which is going to be stored in a special constant here, what they bid, right? I'm sorry, not the winner, the actual bidder, right? So that's what's stored here in who. Get my constants mixed up. But they saw that who bid what, correct? But we can't just say who, because who is it's a network address. So we have a standard library function that's going to help us. We're going to call it format address. And then we're going to pass in the address that we want it to format. And we'll see what that looks like when we get some console logs. What did they do? Well, they bid. Well, and how much did they bid? Well, remember, they're bidding this amount. So again, we're going to say, okay, here's one of our variables, and it's amount. But remember, we parsed it down to micro algos. So if you want to see what that looks like in algos, you need reach to do that for you. Well, we have a standard library function for that. We call it format currency. Remember, the other was parse currency. We call this one format currency. What does that do? Well, that takes micro algos and it sends it back to us, the programmer, as algos. So that we don't have to do that math. It's not that we're lazy, it's just that reach is good. And it takes care of us. What else did we need? Well, we need to show the outcome. Well, that's a function that takes in these two arguments and returns null. So let's have it do that. Let's say show outcome. And it's going to take in those two parameters, which is an address. We'll set that winner constant later. And we're going to say, again, we're just going to log this to the console. Why? Because we need to know what's happening when our app is actually running. Creator saw that. What did they see? Well, remember the address. They saw the winner, but we need to format that. We need reach to format that for us. Format address. What address are we formatting? Well, not who this time, but the winner, right? And there it is highlighting, saying we're using it appropriately. Now let's move on. What did they do? Well, they won with another amount here. We're going to say they won with that same amount, but again, we need to format that back to currency. Format currency amount, right? So what did I say about reflecting the functionality of the backend? Well, the backend, we declare what getSale is. It must be a function. It must take no arguments. It must return this object, right? Here we see that this is what that mirror looks like. Here is the function definition where we give it functionality. We say, log us to the console, send the parameters to the backend, right? Here, when we want to use auction ready, well, we're just calling another front end function that we have yet to define, and we're calling it start bidders, and we'll get there here in a sec. So at this point, we compare these participant interact interfaces in the back with the interact objects in the front, right? Here's our definition of that object, right? The front end provides the instructions for how each function should behave, but the back end dictates when each function should be called and how the participants will interact with one another, right? So this is our data points being fully defined in reach, right? Next, let's turn to, actually I see a question in the chat here that I'd like to tackle right away. Reach does not support negative numbers. There should be no negative numbers in your computations. You can create constants that sort of give you that functionality if you need, but no, Reach does not natively support negative numbers. So now that we've got our data definitions defined, let's move into communication construction. What do I mean when I say communication construction? That is how our participants are actually going to communicate with our application, right? How they communicate with each other, right? So the two differences in our participants here are going to be that one is a participant and one is an API, right? APIs are just those repeat participants that have the same functionality. Bidders 1 through 1,000 are all only going to be able to bid, right? So the participant is unique in that they can store local values. They can store values persistently in their local state, right? They're associated with an account on the consensus network, right? On the Algorand network. API participants all share the same functionality. It's the same type of user. We just want to repeat them. So we use an illustration here where we talk about voters voting on their favorite color, right? So the act of voting is all that each of them is going to be able to do. They could all input a different color if they like. We could have 1,000 different colors, but each one of them is only ever going to vote. That is where we would call them the voter API. But because in our example here, we're bidding, it's the same thing. It's just bidder, and all they can do is bid. Now, an API is unique because it represents the front end pinging the back end only as we need it. So using APIs allows Reach developers to create quieter and more efficient programs that are not as computationally expensive. Now, one stipulation here is that one user must always be the participant because APIs cannot deploy Reach applications. Remember, I said Reach actually deploys your smart contract out to the blockchain. APIs cannot do that. You must have a participant make that deploy, right? So now let's codify what that communication construction starts to look like. Let me get back to my RSH file here. And remember, init says, let's start going through our steps. Well, the creator is the first one and only refers to the local step. What I say about local step, remember local step is just between the creator and their machine. So right now the creator is going to sit at their computer and tell our Reach application what the information looks like. Right? Well, the information that we told it was going to be the NFT ID, it was going to be the minimum bid, and then it was also going to be the length that we allow the sale in blocks, right? So that came from our function here, get sale. Well, all we have to do is call get sale, right? No, get sale exists in the front end. We define the signature in the back, but the functionality lives in the front end. So if we want this to actually work, we need our participant to interact with the get sale function. What's going to happen here is anything returned from this get sale function is now going to be stored in this object, right? Reach is telling me here that we don't like this information. Well, why? Because this information comes over hashed. We need to declassify that information so that it's no longer in a hashed value. Sometimes you will keep that information hashed, but you need to tell Reach that specifically. We're not going to go over that case here, but I like to touch on what declassify actually does, right? So we're going to go ahead and close out what our local step looks like. So now our creator has typed in the NFT ID, they've typed in the minimum block, the length and bids. And now the creator is going to tell the consensus network about that information, right? Publish is a consensus step. Publish tells the Algorand network what these values are. Well, we set them here, and that's great. But now we need to publish them to keep all our participants honest and know that that information is on the consensus network. It's on the Algorand network. Here we're going to set that amount that we talked about to be an arbitrary number of 1. And then we're going to commit to that information. Well, remember, I said I was going to do some of this. So here's me including end-of-line characters when I don't need to. Now commit. Commit tells Reach, that's it for consensus operations. Let's move back to step, right? Well, now we need the creator to actually pay those into the contract. Remember, the contract's going to hold the NFT ID. So there it is. This is Reach taking the NFT from the creator's wallet and the amount that we are defining. Pay puts these values into your contract, right? Remember, your contract's going to have its own account address, and we're going to pay that right into the account that we have there. What is Reach telling me? Exit cannot be used in context consensus step, must be used in step or in app init. Reach is going to keep track of where you are as you're stepping through your program and which steps it's going to allow you to make. This is a little bit erroneous because I'm not done with my code, but that's a good place to highlight what that error sort of talks about. Which step are you in and which actions does Reach allow in that step, right? So now we actually paid the NFT in the amount we declared to the contract. So now let's have the creator tell us that the auction's ready. Well, remember, the creator can just say auction ready, right? But because that's a front end function, we need the creator to interact with auction ready, right? So I touched quite a bit as I did it there, and I've got notes here, so I want to touch on them again. Pay allows participants to actually input value into the contract. Publish is sending this information to the blockchain. What information are we using? It needs to be on the blockchain for us to use it, right? So again, publish deals with information, pay deals with values, right? So now at this point, we've satisfied the requirement to create bidders, and we allow a creator to submit an NFT to the contract. Well, now we actually need to be able to allow the bidders to place bids against one another, right? We haven't done this yet, right? Well, we could create a while loop that loops our program with fork statements based on which case wins that bid, right? And then that would need to update the program with the value and then tell everybody else who's got the winning bid. But here's another key abstraction in Reach. We call it parallel reduce, right? Parallel reduce initiates or starts a race between your bidders, and it enables the Reach app to actually update the highest bidder in a consensus step until the auction ends, right? So if you hear me say, we could do a while loop, and the gears start spinning about what that would look like, let's look at what it looks like with a parallel reduce, right? The name parallel reduce actually comes from the fact that these participants are trying to produce a new state from the current values in parallel, right? These threads are running separately, but we need to be able to have Reach update based on whoever was first. So that's what we mean when we say that it's initiating this race on these forks that updates based on your case or whatever, action satisfies your case. In this case, the highest bid, right? So now let's look at the RSH file. Let's get down here where we can actually start to talk about our parallel reduce. Well, again, almost everything in Reach is constants. And well, we have the highest bidder. This is a value that we want to update. We want to update whatever the last price was. We also want to know, we want to flag for, is this the first bid, right? And that's going to help us here in a second. I'll show you how. What is that? Well, it's a parallel reduce. Oh, a little bit too much on my autocomplete there. I'll take that out. Parallel reduce. What is parallel reduce? Well, parallel reduce is going to update these values at each iteration of your loop, depending on who updates first, right? So what are these values I passed in here? Well, right now, the highest bidder is the creator. The last price is the minimum bid. And is first bid is actually true, right? So here's where those values are coming from. So that's 29 through 33. Make sure I'm not off on my line numbers here on my notes. Oh, I did actually miss one thing. I want to go back up here and make sure we get. We need to tell the contract when this is over. So when is the auction over? Well, we're going to call that end. Reach has this function called last consensus time, if I can spell it. And we're going to add our lengthened blocks. Why are we going to do it this way? Well, remember, the application is actually deployed by our creator. So we don't know what the last consensus time is until the app is deployed. Once it's deployed, this function will grab the most recent consensus time, add on our preset lengthened blocks, and store that in end. All right. So now let's get back into our parallel reduce and what we're actually working on in our parallel reduce. This is an abstraction of a while loop. Reach requires invariance for our while loops. What is an invariant? It's a thing that does not change. It's invariant. It does not vary, right? Well, what does this say in English? Well, it says that reach, our contract will, before, during, and after this loop, our contract balance will always contain the NFT equal to one amount. Reach will check this at every iteration of your loop to verify that this is accurate. And this is what we mean when we say that it's creating proofs and it's verifying the actions based on your logic. What is our next invariant? We have another invariant here. Well, the balance of the contract must also hold, well, that's going to vary a little based on which bid we're on. Well, if it's the first bid, it's not going to have any balance, right? But if it is not the first bid, so this is ternary operator, right? If it's true, 0. If it's false, give me this value. Well, it's the last price. So now let's go ahead and actually initialize our loop condition here, right? So we say dot while the last consensus time is less than or equal to end. Remember, we set end ourselves, right? And then we're going to go ahead and create our bidder API. What does this look like, right? This is where our repeat users can come in and bid, right? We'll get a little bit more into this here in a second, but let's just go ahead and create that for now. So the API macro that I'm describing here, I'm showing this API macro right here. That's what this underscore denotes, the macro. API is going to have consensus checks. It's going to check our values against the consensus network and verify that these are accurate, right? API macro means that it has the same check for the consensus operation and for the local operation. So each one of those is the same. Using this macro allows us to just create one check. It's less code and a little bit easier on us as Reach programmers. Okay, so I'm going to leave a space here at 38. We'll have something for that later. 39. We're actually going to return what the bid is. I'm going to call that notify. How does this look? Well, we need to notify. What do we need to notify? What values do we need in here? Well, we need to notify of the highest bidder and of the last price. Okay. Well, what's next? Well, we need a conditional if it's the first bid because there's a special case there, right? So is this the first bid? If it is, what do we want it to do? Well, we don't want it to do anything. But if it's not the first bid, well, then we want to transfer the last price in algos to the highest bidder, right? We're going to create a call in here for who is calling, right? So here on 44, we're going to use this. Those of you familiar with this pointer. In Reach, it's a little bit special. This points to the contract caller. Remember, this API can be a repeat number of different users. What this does here is store which user it is and who, right? Now we want the creator to do something. We want them to interact with what this bid was. Give us the address for who it was and what the bid looked like, right? And now this is where parallel reduce actually updates its values in these return statements, right? So now we're telling Reach, return these values, right? Highest bidder, last price is first bid. Well, we know now this who is the highest bidder. This bid is the last price. And is this the first bid? Well, not anymore, it's not. So let's turn that to false. Okay. That's how we update information inside of our parallel reduce, right? Now we're going to look at a timeout function. Timeout is necessary to keep our participants honest so that you can't just time out of the application with somebody else's tokens in it, right? So we're going to say .timeout, and Reach provides a bunch of different time arguments. This one we're going to use as absolute. There's also relative time, which denotes the consensus network. But here we're going to say absolute time. All right, when absolute time reaches the value stored in end, we need the creator to make a publish here. This is a requirement inside of this action that we be in a certain step and that be in the consensus step here. Remember, publish puts us there, and Reach will tell you if it does not like that. So we also need to update our values in this case. Well, in this case, the highest bidder goes to that. We store the last price. And whatever is in his first bid is what we want it to be. We're not actually changing that here. We're just passing it back. So here's the end of our timeout logic, right? Now let's actually make our front end bidder logic. We need to go to our index.mjs file here, right? And scroll back up to where I left a lot of blanks here, probably too many that I'll have to correct later. So we are going to, again, implement the front end bidder logic. How does the front end bidder actually bid, right? So up here on line 17, we're going to create a variable to let us know when done, right? And at first we're not done. And we're going to create an array of our bidders so that we can store those, right? Now line 20, I'm sorry, 19 here is actually going to create that function that we talked about called start bids, right? We need to await, so it's going to be an async function, right? Again, I can't get away with avoiding these in the front end. Let's include it there. What do we want this start bidders to look like? Remember, this is triggered when the creator says auction ready. So let's store this local minimum bid inside of bid. And then let's create this run bidder function, right? And this is also needs to be async because we need to await it. But this one's actually going to take in who is calling it, right? So run bidder, right? Let's store this in increment here. Typically you would get the bid from the user, but again, we're doing this in a local DevNet. So we're going to create a random function for the bid, right? What does that look like? Well, we're familiar with math.random, right? Well, let's make that up to 10. Let's give us a random number between 0 and 10. Well, remember, it's going to be an algos, so we need the stdlib to parse that currency, right? I do this a little backwards just for instruction's sake so that we kind of get that feature down. Now let's say the bid is equal to the bid.add.increment, right? That's what our bid looks like. Now let's start creating our new accounts. Remember, we had to create a test account for our creator. We need to do the same thing for our bidders here. So let's say const account equals, well, we're going to need to await the std library to also, standard library to also create us a new test account. And we're going to fund it with the same starting balance, not bidders. That's the wrong starting balance. That's the one. It's a very nice feature until it doesn't work. Okay, and then we're going to set a special debug feature here that's just going to help us with some error messages if we are to get them. And this is a presentation, so we'll likely get some. And then, well, if you're familiar with the Algorand network, you know that we need to opt into our tokens. We need to opt into things before we're allowed to receive them. So let's have them opt in to the NFT ID, right? Now, line 28, let's actually push our bidders array with that address. Who? Well, the account address. right? Now, 29, let's attach the API participant to the contract. How do we actually get them to do that? Well, first we use the right reference for const, and we say CTC equals that account.contract. Remember, account.contract. Well, we want to attach to the back end, but instead of now the standard contract info, well, we need to attach to the same contract that the creator did. So we need that creator's contract info, and we need the function here that's going to say get info, right? So this actually allows this account to attach to this given backend. This is how we attach to the same contract that's out there, right? Now on line 30, we're going to go ahead and create a function called get balance. We'll shorten that to get val. It's an async function, so we'll need to await. Oop, typed correctly. Remember, I said I'll match the keyboard so I get it right. Well, balance is probably going to be in a currency, so we need the standard library to format it for us. And then we also need it to await the standard library to get us the balance of that test account, right? Well, balance of that account, right? So we'll stay in our MJS file here. We'll move down a little bit. I may have an erroneous, that looks like an error. Well, hopefully we'll see when the compiler yells at us. So let's jump down here to line 32. And let's actually give us some more console messages. Remember, I like to know what's going on in our app when we test it like this. Who decides to bid? What are they bidding? Well, they're going to be bidding an amount of currency. So let's let the standard library help us here with the format currency function. And let's say it's the bid. Yeah, I think that's all I need here. And then we're going to do another console log here. And what are we going to need in this one? Again, we want to know who is logging. We're going to grab their before balance here. This allows us to test for how much is coming out, verify whose account addresses are actually being actually having funds taken out of and where they're going. So we'll say the balance before is, and again, this is just our helper function, and we need to await the promise of that get balance account. Okay, that looks good. So now we've created the first half of this bidder's communication model, right? Bidders now have the logic that dictates their behavior when interacting with the contract. The communication model allows this bidder to enter a race with another bidder and ensures that they are aware of the highest bidder to beat at all times. Now, if you're thinking through your head on how to actually build that, it's a pretty complicated procedure to keep up to date with 1,000 different bidders. Parallel Reduce is taking care of all this for us. So we like to say that there is a very clearly communication defined model, and that's extremely important because we know in Web3 there is no middleman. Our decentralized applications create an opportunity to reduce the fees and increase the velocity of our communications and funding. So in this case, instead of waiting for the highest bidder to wire credit, the network tokens are escrowed the moment the bid is placed and then transferred the moment the auction closes, dictated by the program logic, right? Now we're gonna look at what we talked about, assertions. We're gonna talk more about the verification engine, the reach verification engine, right? Assertions in reach can be static or dynamic. Static assertions, written as assert in the backend, are always true throughout the life of our application. Dynamic assertions may vary in truthfulness based on the state of your dApp, right? Dynamic assertions in a local step use an assume and a require in a consensus step. Remember, reach has removed the need to remember when to use which dynamic assertion with the check method. Check will automatically determine which mode of your app is in use, and it will give the appropriate dynamic assertion on your behalf. A small abstraction that helps write less reach code. So let's return to these missing pieces that I've got in the app and populate them with are assertions, right? So that's in our backend RSH file, right? So up here, 27, make sure I've got my file open correctly here. 27, assertions. We're going to assert. It's a reserved keyword, assert. Well, balance is going to check the balance of the contract for the NFT ID and check that it's equal to the amount. If that is not correct, it's going to tell us the balance of NFT is wrong. Right? Next, we're going to jump down a little further. I left a space here, 37 to 39. Right? 38 is a dynamic assertion. Right? This provides a local assumption that the incoming bid is greater than the value stored in last price. Or it throws that the error is false. What does that look like? Right? Well, we're going to check that the bid is greater than the last price. And if it's not, what are we going to say? Well, we're going to say the bid is too low. Right? So that is our back-end assertions. Right? We're checking for this value each time it updates. Right? We're asserting that the contract balance always holds the NFT at this amount, right? The verification engine is going to check those things for us, right? And if there's any way possible that that could happen in our code, Reach will tell us, hey, I don't like that. And you're going to have to go back and make sure that you're paying amounts and NFTs into your contract appropriately and that you're transferring them out also appropriately. So that's it for backend assertions. Let's move back to our front end. What's a common exception data structure, right? Try catch block. We're going to use a try catch block here, right? Underneath of our get balance. What are we going to try? We're going to try to get a bid, right? So we're going to store that in const last bidder, last bid. And then we're going to await this contract info from the APIs, the bidder APIs that is, and their bid function. Who used that bid function, right? Now I want a console message. I want to know what happens here if we get to this point. All right, so we'll say console.log who outbid, right? Because if they get to this point, the bid is higher. The last bidder who bid. What did they do? They bid. Well, we need a format currency here because this is going to be an amount. So we'll just say format currency. And how much did they bid? Well, I think it was just last bid is what we said there. Yeah, we said last bid there. Okay. Well, what happens if that fails? Well, we want to catch the exception inside of this parameter E, and then we want to let it know console.log. Well, typically the exception here is that who failed to bid because the auction is over, right? We're past our time, right? After that, let's update the console with what our balance is like so that we know what this looked like. So we'll say who balance after is, well, we have a function for that, but it's an async function, so we'll await it. We'll await the get val, and it'll return for us, right? So this line 40 here will wrap that, and that will print the bidder's balance after their API. So our app is almost complete. There's only a few small sections left. We talk about transfer patterns, how the actual tokens and ASAs and everything are transferred in and out of our contract. So in our logic, the NFT is transferred to the highest bidder at the end of the auction. And if it is not the first bid, then the last bid amount is transferred to the creator. What does that look like? Well, let's get back to our back end. This is a nice, short, compact contract. I really love the features that you can pack into these reach contracts and short code stints. So what do we need to do now? Well, now we need to transfer. This is a special function in reach, transfer. What do we need to transfer? Well, we need to transfer the amount of NFT IDs to the highest bidder, right? If it's not the first bid, backspace is my favorite key sometimes, I swear. Well, then let's transfer the last price to the creator. Remember, this is who we set as our participant, the creator, so we can send it directly to them. And then we want to see what the outcome looks like. Well, we have a function for that as well. It's a creator front end function. So we're going to creator.interact with the show outcome function. We're going to pass it in the highest bidder. We're going to also pass it in the last price. Okay, that's great. So we'll stop there and move back to the front end for this transfer logic in the front end. All right. So now way down here where I've left probably way too much space. Yep, absolutely. There's way too much space there. I'll deal with that here in a minute. Actually, why don't we go ahead and get it back to where it should be now. Let's say it's, that looks right. Almost. Oh, we can add them from there, 68. Okay, so this is what our transfer logic looks like. We're going to create a for loop for our constants of who and their count of our bidders array, right? Anyone in our bidders. What are we going to do? Well, we want to know the balances of all of our accounts here based on this transfer. What happened during the transfer? Whose balances are what? Well, we need a const for the amount of NFTs. We need to await a standard library function called balances of, notice the plural, the account, a null value, and an NFT ID. Then we want the console to tell Nick, the programmer, what's happening, because Nick likes to know what happens in his programs. Again, these messages are a little bit for you as a developer, because once you start implementing front ends, that's not exactly the way you'll handle it, but is best for your testing environments. Again, this is a DevNet testing environment, and that really helps you kind of test your programs quickly. So let's format our currency back to the amount, and then also give the standard unit of the network that we're on. So std libasol has a function for that. We call it standard unit. Okay. And then what else? Well, that's algos. It's going to return us there. It has X amount of algos. Remember, standard unit is algos. And then we're going to also check the balance for the amount of the NFT. Right? So amount NFT of the NFT. Great. So that is the transfer pattern on our front end. I'll look at it here again. We're going to for loop through all of our bidders. We're going to tell what our balances look like. Right? So now let's create the actual API bidders. What does this look like? So in our front end, we have helper functions here. And on 43, we'll start there. We'll await the creation of run bidder. Remember, we created that function. Call them Alice. We'll await run bidder for our next bidder. We'll call them Bob. Well, and then we'll await run bidder for our next participant. We'll call them Claire. While our variable done is still true, let's move it forward. Let's move the auction forward. We need to manually force the auction to move forward because we're in a DevNet environment. It's going to grab the wait is going to wait 1 block and move us forward 1 block until we're done. Remember, we set the lengthen blocks as our end time. So we need to move the network forward 1 block each time there. So again, that's what we would need to do in this local environment. If we were in an actual test net or an actual main net environment, you're going to have your bidders attached to the application. If you've used DeFi, if you've used Algorand apps in the past, you have to get your phone out, scan a QR code. Well, that QR code is attaching you to the contract, right? That's what's happening. So all of the things we do here with creating test accounts and funding them with test tokens, that's not necessarily once we start getting into the actual front end application. So we're just about there. We're almost done. So every other task is complete here. So let's move back here and let's destroy our contract. Destroy it? No. Yes, the actual application will destroy your smart contract determination of the functionality. What does that look like? Well, we need to commit to all of the information we've given it, and then we just exit. Right? We just exit our application, and then it's going to destroy the contract for us. Right? Now, the last thing we need to do is go back to our front end, clean up some of these spaces. And remember, we have a done variable of which we're using as a flag. So we're done. Let's set it to false or to true. Right? So done equals true. And we are done. That is an entire Reach application. 73 lines of front-end JavaScript, 59 lines of back-end Reach code. This is ready. Well, at least I think it's ready. We'll let the compiler tell me if it's actually ready. Well, we called this present3. So let's get into the present3 folder. Show me the files that are in there. Well, let's let Reach compile those files. Reach compiles only going to look at your RSH file. That's a problem. Okay, I'm thinking that the issue here is likely because I do have an RSH up here at the top. So it is there. So there's some other image hash issue. Remember that we're actually going to spin up an environment, your own test environment. And sometimes old build artifacts and image hashes end up in your environment. Luckily, I have a backup. So let's just jump to our backup, right? So ls, let's see, cd present. We name our folders appropriately here. So, okay, well, that one's got an old build folder that works. So let's have it, let's clear this up so we can see what we're looking at. Okay, so this is the same exact code I just wrote, and we'll tell Reach to compile. Okay, well, remember our first scaffolding app was 7 theorems. This is a little bit more complicated. We created 48 theorems here, right? Reach checked for when all our participants were honest. They were doing what they were supposed to. Reach checked when all participants were dishonest. They were doing the opposite of what they were supposed to, or they were trying to break your application. Not possible. Reach checked all 48 of those theorems. We had no failures. Well, remember, we want our application to run on the Algorand network. Reach is blockchain agnostic, so we run on different blockchains. Today we're running on Algorand. Reach connector mode equals algo. You can also export this into your environment file, but I like to do this for presentation purposes. Now let's Reach run our application. Let's run our auction. What does this look like? There's Nick's abundance of console log messages telling us what happened. Let's get through this, okay? Well, remember, it checked all of our theorems for us. It created your Docker images and got you ready to run on your local DevNet. And it says, okay, well, I'm going to create a test account for the creator. I'm going to have the creator create a testing NFT. They're going to set the parameters of the sale. And here's what the actual number looks like in Reach, right? It's an object. It's a big number object. And then we're going to start our bids. Alice decides to bid 870 or 887. Here's our balance before. Well, she outbid our minimum bid, so we're going to take her money. We're going to store it in the contract. Bob bids 16. Well, that's more. So here's his before balance. We show that he outbid Alice here. And then we took the 16 from Bob's before balance and we put it into the contract. Next, Claire decides to bid 22. Her balance before is this. Oh, the auction's over. She failed to bid. No money was taken from her account. The creator account saw each of these bids. They saw the winning bid here. And now Alice ended up with the same amount. Bob won the auction. He's taking home the NFT and he's losing his 16 algos. And we're showing that Claire did not actually bid. That is our entire NFT auction deck. It behaves exactly as we expected, and it consists of minimal code for maximum functionality. So I think here, if I even remove the few spaces that I do have, I'll leave the one at the top there. That's 57 lines of reach code. 57 lines of reach code. Oh, good catch, Venkat. Thank you. Yeah, I probably just didn't save them. Let me see. Yep, there it is. Save all. Don't forget to do that. So you can save your files. I think Control S will like manually save them for you. Just the one, jump over to the other. Let's check and see if it actually worked. So that is Reach. That's the overview of Reach. That's what our auction app actually looks like. And we built that in less than 90 minutes, like 60 minutes. Obviously, I've got some Reach experience, but you start learning to think about the way that these Reach apps are built, and you will also be able to start quickly moving through these Reach applications. So let's just for peace of mind. I'll go ahead and take any questions here that we have. I'll start looking through the chat. I know I talked for the duration of the time here, but let me look through and make sure we don't have any other questions that we have. Does Reach support date and time? I want the auction to run for 10 days, highest after 10 days. When's the auction? Well, absolute time, but I think it's in seconds, so you'd have to make some conversions. But yeah, you can use absolute time. Relative time refers to network time. So if you know, on Algorand, we're talking about blocks, right? It's a lot more consistent on Algorand than other networks. And I love testing and running things on the Algorand network. I can deploy my app to mainnet for nothing, and actually try to get it to work. So has anyone used PyTeal and Reach? Which do they like better? I've used both. I'm partial, so I'm obviously going to tell you Reach, but the key difference between PyTeal and Reach is you're going to have another layer of abstraction with Reach. We've implemented a lot of features to help you write programs that compile to smart contracts, and you're going to have a lot less interacting on sort of a finite level with a lot of the moves you need to make. This same application in PyTeal, I'm sorry, not this application, the rock, paper, scissors one. I think it's 3 or 4 times the amount of code, and it's maybe Python's a little bit more familiar to you, but yeah, I would say the benefits of Reach in that situation are abstraction and the formal verification. Nobody else includes this mathematical proof structure to try to break your program, right? Web3, you're kind of just out on your own. If it breaks, you better have some expensive backers to help you supplant the millions of dollars that were lost, right? I can't find, I'm going through the team formation page, but I can't find anyone to add. Okay, if you're trying to get formed up on teams for Emoja 3, it's a little different, but go ahead and reach out to me directly, and I'll make sure to get you hooked up with a team.
Nick, there's also this one in the Q&A that says, can we deploy with any NS available NW available in the market using Reach, or only on specific networks?
Yeah, so specific networks currently that we support are Algorand, Ethereum, including layer 2s, right? So Polygon, all of your layer 2 EVM compatible chains, and Conflux, which Conflux is it's a Chinese blockchain. They're the only legal blockchain that actually operates in China. So those are the 3 that we currently support. I know that the Reach team is expanding support. We have a team that that's all they work on is which networks are next. So I know that there are a lot of popular networks in talks right now, and they will eventually be able to deploy to that same to deploy to those networks. So if you want to verify, I know that we're presenting here for Algorand. So I'm sorry. We'll get into this folder, and if I wanted to say the reach connector mode equals ETH, it'll do the same thing. And it'll show me Algorand, or it'll show me Ethereum addresses, and it'll connect to MetaMask and connect to the Ethereum network. So one thing I do like to show, remember I said that we compile down to this build folder. This build folder contains that index.mjs, right? Let's close down all this stuff, get you out of here. Check this out. This is what is compiled from your Reach application. Remember, 57 lines here, 70 here. This is the JavaScript that's compiled for the middle layer before we compile the teal. And this is what it looks like. This code is over 1,000 lines long. Look at this. I'll jump all the way to the bottom. It's too long to scroll. It's too long for me to scroll. Look at that. It's 1,076 lines of code. We wrote that in a backend, 57 lines of Reach code. Reach did the rest for us. This is not where it stops. Those of you who are familiar with teal, it's a stack-based execution language. There are more lines of teal than there are of JavaScript. And again, this is our middle layer, right? We're importing this into our front end so that we can interact with it. But once we tell Reach, hey, I want to run on Algo, it takes this file and breaks it down into teal. And there are thousands of lines of teal to this program, 3,000 or 4,000 lines maybe. So that's where your abstraction really comes into play. Is there any Reach features that only work on a specific chain? There are a couple like strange features. One example is like local storage state or local storage volume allowed on Algorand. That's going up, which is a great thing for us, but we are limited in some aspects to which network we're connecting to and how they handle things. So there are some small hiccups there. There's nothing really that I would say is like a catastrophic failure where you can't run on the network because of that. We haven't seen any of that. So do all work? No, like I said, it's not without issue. There are very few issues, and most of the times you just handle them as a programmer, and then you don't, your front-facing application never sees that flaw, right? What are the best Git repos or projects you can share for dApps with a web front end? Well, if you're looking to get like a web front end, if you're looking to build a Reach program, the rock, paper, scissors tutorial comes with a React front end. If you need to, you can use that scaffolding, gut the features, and add what you need to it. It is class-based React. So those of you who are super familiar with React and use hooks and like never want to use class-based React again, I'm sorry. It's currently class-based React. We are working on adjusting it to a hooks program. So we did okay on time, I think, right? About 100 minutes. So
yeah, not too bad.
Yeah, good. For winning the hack, I don't know about that. I don't know. My first suggestion would be to write it in Reach, but then my second would be to make some friends. I'm not sure.
Yeah, I would say that from my insight into this hackathon, I would look at the bounties on Monday because there's a lot of some insight from the Algo community on what they hope to see and what they really wish to see. So I think the bounties will give you a lot of more insight into building a project that would be really, insightful. But I think one of the things that I've noticed in hackathons themselves is when you find a community that's somewhat familiar, with Algo or Reach in general, and they're like, wow, we wish that there was this functionality in it. And then they build a project around that. That usually tends to be the ones that are the community winners. So there's a community voting element of this, which means that your peers are going to be voting as well. And, it doesn't have to be the most flashy app, but something that does something that solves a problem for a great amount of people is always good.
Yeah, my recommendation, and I coordinate these bounty hacks for Reach, build functionality. Don't worry too much about it being pretty on the front end. Make the buttons there and the inputs there. Do what needs to be done to make it work. But all your functionality should be packed into your contracts and packed into what it actually does. What problem does it solve? And then once you win the hackathon, you can start really working on your front end and making it pretty,
100%. Totally agree. All right, Nick, that's all I see question-wise. Let me see if there's any questions in the, So there's a couple of questions in the YouTube, and one of them is, will the repo of this code, will there be a repo for this code? So is this public anywhere where people who are watching this can actually go through the code?
Absolutely. Let me drop you what where the repo is. So first, just to say, Reach has a public repository for all of our examples where we try to highlight different features of what Reach is. You'll see that here, GitHub Reach /examples. That folder holds a lot of actual Reach code. Then the next folder in is our Nft Auction API, which we just implemented. There you'll find index.rsh and you'll find index.mjs.
This is so helpful. Great.
Yeah.
Nick, the other question I'm going to ask for is there any other developer doc? Like, do you have links to the developer docs that are helpful in Reach that would be helpful for those who also are trying to build?
Yeah, I mean, our general documentation has been undergoing upgrades. The thing with a language like ours is as we continue to add features and we add things, we realize what the community needs, what things do we need to add, and it's always being updated. I would say that you could learn from the docs themselves. I'm a product of that myself. I took a Reach bootcamp and then spent 2 months with the documentation, and I ended up very well understanding Reach. And like I said, it's something that we've actually had. We had a weekend hackathon just a few weeks back, and we had 2 teams that we sent there. One team had never written any Reach code at all. The hack was 36 hours long. They were able to learn Reach, build an application in Reach in that 36 hours, and they won 4 different awards. They won 4 different awards because you're not worrying about, oh, well, the teal stack expects this value. I need to pop the value back off the stack, push it down onto the stack. You're not worrying about that low level, how do I interact with the node? Reach has done so much abstraction to get you away from that hardware that you can learn Reach in a weekend and turn around a project that wins awards. And I mean, it's happened more than once. So that's where we really pride ourselves on what the documentation looks like and how easy the language has been structured to learn if you have previous experience.
That's awesome. All right. Well, I don't see any other questions in the YouTube or the AirMeet. And thank you for those of you who are joining. So with that, I'm just going to go ahead and say, Nick, thank you so much for taking this time to show us Reach and going through this application so much. It was really insightful. And thank you all for joining us. Don't forget the kickoff is on Monday, and that's when the bounties go live. So you'll be able to take a deep dive into the bounties, see what all the awards are, and get started. So enjoy your weekend. If you need any help, please reach out to the Algo team in the Algo Discord. And if you need any other help, feel free to reach out to me. I'll be more than happy to help you out as well. But other than that, everybody have a great rest of the weekend and get happy hacking. All right. Bye, everybody.
Thanks, everybody.